So that is the continuation of the last experiment we had. Today we want to plot the graph and answer other questions. First and foremost, let's look at the precaution. Precaution number one, I ensured rigid setup. So ensure that the setup is well fixed to avoid it falling off when you are performing the experiment. Number two, I avoided reduced to parallax on the meter rule. You must mention the apparatus you use. If not, it becomes zero. Number three, I avoided zero error on the meter rule. You also mention the apparatus. Number four, I avoided draft. D-R-A-U-G-H-T. That draft here simply means strong wind. Strong wind. So you put on the fan, you close the window if there is strong wind. Not D-R-O-U-G-H-T. That one means scarcity. Okay, then let's go to the graph proper. We are plotting log T against log L. So first thing we'll do is to have our approximated table of the values we want to plot. So at this point, let's go to the graph. So my graph is actually small. It's not my standard graph. So let's see what you can do out of it. So here I'm using 0.02, 0.04, 0.06, 0.08, 1 point, we have 0.10, we have 0.12, then 0.14. So here I'm using 0.2 scale to 2 cm, that is 2 cm to 0.2 rather. So okay, we have distinguished the axis. You are plotting log T against log L. If you not put that, you have lose 1 mark from the graph. So first and foremost, we are plotting log T 0.097. When log T is 0.097. So we come here, count 5 lines. 1, 2, 3, 4, 5. This is 0.09. Then one line represents 0.002. So 0.09, 0.092, 0.094, 0.096. So 7 is in between. It's between 0.098 and 0.096. So we take it to where we have 1.9. So here is 1.8. So count 5 lines. 1, 2, 3, 4, 5. Take it straight to, this is the graph, to this point. Okay, no, this is where I'm plotting. So better still, just take this one off. Here is 0.098. Here you're plotting here. 1, 2, 3, 4. You're plotting at this point. Normally we plot at the point of intersection, but since we have such value, we have to plot there. So when it's 0.063, we have 1.85. 0.063, 85. This is 8. We take it to 6. 6.3. Since one line here is 0.02, so here will be 6.3 here, and here again we have 1, 2. So going to be somewhere here. Normally we don't plot inside box, but because of the values we have, so I have 0.049. When it's 0.049, it is 1.78. This is 0.04, 1.78, is on the fifth line. 1, 2, 3, 4, 5. 1.7. 1.78. 1, 2, 3, 4. This is 1.78. And we are looking at 6, 3. This is 6. So you're plotting exactly here. Alright? So we have 0.013 is 1.7. 0.013. Okay? 1.7. This is 1.7. 1, 2, 3, 4, 5. 1, 3. 1, 2, 3, 4. This is 0.01. This is 2, and 3 is here. And the last one is minus 0.043, and then is 1.6. 1.6. Okay, we didn't complete our value. Sorry. Minus 0.02, minus 0.04, minus 0.06. So here you get to 0.04 is 0.04. 43 is here, and then we get our slope. Okay, so our slope, when you are joining your line, ensure that you take note of line of best fits. If you have point that not enter the line, then they should not be one-sided. One can be, if you have, for example, if in this graph and I have 3 points that enters the line, the remaining one, the remaining 2, one can be here, the other one here. If 2 of them are one-sided, you will lose mark for line of best fit. And secondly, use transparent ruler. This is not transparent ruler. The reason is when I put this here, I will not be able to see the points clearly. But let me try and see what I can get out of this. Okay, let me check these points. Let me check this too. Check whether it will pass through that point. Okay, and you rule. Now you can see this point, this and this did not enter, but 1 and 2 are this side, and this is here. So you have line of best fits here. So you can choose your slope. Say get your slope. So let's check. Our slope can be here, any point of intersection. Let me take this as my slope. Your slope should be as large as at least 1/3 of your entire graph. This is my slope. This is my slope. Okay, slope here is equal to change in log t over change in log L, which means this point is here is 0.12345. Here is 0.11. 1, 2, 3, 4. This is 0.18. 0.18 minus here is 0.004. 0.004 over this one, which is 2.0 minus here is 1.6, 1.62, 64, 68, and then 7. So here is 1.7. 1.7. So we evaluate. We have 0.118 minus 0.004. It gives us is equal to 0.114 over, this is 0.3, is equal to, divided by 0.3, that will give us 0.38. This is an intercept. So we have asked, this is our slope rather. We have gotten our slope, and then the intercepts on the vertical axis. Unfortunately, because I said initially that my graph is not standard one, I will not be able to, this is horizontal axis. I will not be able to get my intercept there. Okay, then the next question, state the precaution, and then define simple harmonic motion, which is B1. So in WAEC, from everything we have done till this point, we give you 21 marks. This is 2 marks, another 2 marks. That will give you total of 25 marks. Alright? So I want you to do this. You can use my table and then plot your graph, answer this and this. You can post it to me on the comment section or send it to my DM. If you have any question, feel free to ask me. I'll answer you. Thank you, and thank you very much. Bye for now. See you in the next episode.